All right, welcome back, everybody. Hey, for those of you playing along at home, it would be a good idea if you pause the recording right now, did this warm up, and then press play, and we can go through it. Remember that today is just going to be a review over Chapter 6, Section 6.1 and 6.4. Yes, I am recording up here, so let's be quiet. Section 6.1 and 6.4. We're going to go over the practice test. I know normally we would write on the whiteboards, but there's only 11 questions. And that'd be kind of weird to have just 11 people writing them on the whiteboard. So I'm just going to go over them. And I'll go through every problem, and we'll talk through all the questions, and we'll go from there. Does that sound good?
Yeah.
Okay, so again, if you've not already done so, please pause the recording, people at home, and pick up when you're ready. All right, number one here, solve by substitution. And again, please read the directions. Read the directions. I don't want it to happen, but there will be someone tomorrow who answers the question in the incorrect method. Right? Somebody's going to try to do elimination when I tell you to do substitution. Or somebody's going to try to do elimination when I tell you to do, you know what I mean, the wrong thing, right? Or somebody's going to just try to do substitution or try to do elimination when I tell you to graph. Obviously, if there's a graph sitting there, I want you to graph, right? But please read the directions. Even if you get the answer right, but you do it in the wrong method, I will not give you credit for that. Just like on the practice test, there are some where you have to do it by graphing, some by substitution, some by elimination, and then there's a good majority of them that you get to pick. All the word problems, you will be able to pick which ones you'd like to do, or which method you'd like to do. All right, let's take a look here. Solve by substitution. What's the easiest way to solve this for substitution? Mackenzie?
Subtract 3y.
Good. Let's take a look at equation 1. Notice that in equation 1, it's x plus 3y. So all we would need to do is just get 3y over to the other side. So let's do that. Here's equation 1. So all I'm going to do is take x plus 3y and subtract 3y over to the other side. So that's going to get me x is equal to 15 minus 3y. Okay, because the goal is to try to get one of the variables completely alone. Did I do that? Did I achieve that? Yes. I have no idea why, but there are so many people out there trying to put both equations equal to y. You don't need to do that. You don't need to solve for y in either of these two equations. That's graphic. That's not substitution. Makes me think if you were out, you weren't watching videos or something. I don't know where you got that. But anyway, it was out of equation 2, it was 2x minus 3y is negative 6, right? It was 2x minus 3y is negative 6. So I am going to replace the x with 15 minus 3y. Do we see that? All I did was remove x out of the bottom equation, and in its place, I put in what we solved for. We solved for x. We got it to be 15 minus 3y. We plug it in. And now we solve. 30 minus 6y minus 3y is negative 6. All I did was distribute in the 2. I combine like terms. Negative 6 and negative 3 make negative 9. I subtract the 30. I get negative 9y is equal to negative 36. I divide by negative 9. I get y is 4. And now all I need to do is solve for x. Now, I've got an equation here that's already pre-solved for x. X is equal to 15 minus 3 times y, but y is 4. So x is equal to 15 minus 12. So x is 3. So my final answer is 3, 4. Questions about that? All right, let's take a look at the next one here. The next one says solve by elimination. Mr. Richard Massenheiser, everybody, he's right here. That's the man, the myth, the legend. I'm recording, be careful, I'm recording. Oh, geez, this is a hallway conversation. Can't be recorded. Yes. Yes. Alright. Oh, back. Here it is, right here. What's negative 6? Negative. You are the positive. I got the negative. Which was negative the positive. Look, we got 4. We might need 4. But you are the negative. See what I mean? So let me show you this. Like, I don't run away really. I would only take a whole point. Because I see when you close the negative. I don't think you plug it in there. Everything else is right. It's somewhere in this negative rule direction. I'm just being track. Does that make sense? Yeah. Be careful. I mean, it's still, I think when I did it, it's still. Still equal what? Oh, on the top, you mean? Oh, well. Point it back to the aggregate. Let everyone have back into the equation. It may have for the first, but it may not have for the second equation. That's the thing. Yeah. Hold on a second. Baker, Carol. I'm sorry.
You have to plug in for the opposite variable. It's why you have to plug in for that.
Yeah, once you get down to one variable, you got to find the other one. Yeah? Is that what you're talking about?
Yeah.
So once you get like a y equals, you got to plug that in for y, but you're really solving for x. So y equals 4. I go back in here, I replace 4 right there. Then I solve for x. Okay. All right, let's take a look at the next one here. I want to solve this by elimination. So what do I want to eliminate? Do I want to eliminate x's or y's? You want to eliminate x's? I would like to eliminate x's because one's negative, one's positive. I'm not going to have to multiply by a negative here. Okay, that would mean I would multiply the top by 3 and the bottom by 2. Get them both to be 6. The top, negative 6x plus 15y, negative 3. Positive 6x, positive 4y, positive 22. I add down. Always add. I get a 19y is equal to 19. Hey, look at that. I divide by 19, so y is 1. I plug it back in. You want to go bottom? Let's go bottom. 3x plus, it would be 2 times 1, but let's just say 2. 2 times 1 is just 2, so we'll just put it over 2. We subtract the 2 over to the other side. We divide by 3. Okay, questions about that? That would be an issue. All right, let's take out our practice tests. Let's go through question by question, and I'm going to have to screen capture this off here. Oh, I put it in a weird spot. That's right. There. All right. So your job right now is to check as we go. Okay. Ask questions where we need to. Stop me if you have a question. You know by now. I mean, I'm a pretty, I don't know, predictable guy. What do you think your test is going to look like? Very similar to this, right? Very similar. All right, so why am I saying do not solve? What I mean by that is that don't use substitution, elimination, or graphing. I just want you to check your answer, basically. I saw a lot of people, when they were doing this, working on the practice test yesterday, trying to actually solve, like doing elimination. No, don't solve. You do not need to solve. You're doing way too much work. Look, equation 1, 2 times negative 2 plus 5 equals 1. All I did was just plug in negative 2 for x and positive 1 for y into equation 1. Negative 4 plus 5, is that 1? Yes, it checks out. Now I just have to check the second equation. Equation 2, 3 times x minus 3 times y is negative 21. And I just check to see if the left side equals negative 21. Okay, negative 6 minus 15. Yep. That checks out. Is negative 2 comma 5 the solution? Yes. Questions about that? Okay. Again, this is all going to be recorded, so if you need to go back and rewatch these things, it'd be a great idea to go back and do so. Number 2, y is equal to 2x minus 6 and y is equal to x minus 4. Pay attention if you need help with graphing, folks. Ridiculous how many people need help with graphing and not saying anything. My top line I'm going to put in red. So the m is 2, the b is negative 6. Okay, where do I start? Do I start at 2? Do I go here to 2? No. Where do I start? So here? No. The y-axis down here at negative 6. Now, slope of 2. That means rise 2, run 2, right? No. The slope is 2 over 1. Rise 2, run 1. Rise 2, run 1. And it should go up and to the right. This is a positive slope. Look how many dots I'm making. And again, it might be a good idea to bring your straight edge, so you don't miss points like I did. And then, let's graph our blue. M is 1, B is negative 4. Okay, so I come down here to negative 4. I make my dots up 1 over 1, up 1 over 1. Look, it matched right there. Right there. Sorry, I know my line didn't look like it matched, but the points were there. That was the coordinate. So where is that? That's 2 comma negative 2. Questions about that one? Okay, let's take a look here. Top equation I'm going to put in blue. Now, To graph them, I need them put into y equals form, right? To graph them, I definitely need to put them into y equals form. So I need to solve for y with that equation, which means I add 2x to both sides. And yeah, this does mean that I have to put the 2x first. And then I divide by 2. Now, folks, remember that you divide 2 to everything. I put the 1x out there just to show that the slope is 1. But 2 over 2 is just, 2x over 2 is just x. Questions on that? Make sure you didn't write 2x minus 7. Or make sure you didn't write x minus 14. The slope is 1. The b is negative 7. Okay, negative 7, slope of 1. There's my line. Pretty good on that one. Let's take a look at the other line. Now the other line is not so bad. All I have to do is just subtract x over. But be careful. I would bet, if I were a gambling man, I would bet that most of you made your issues by taking the wrong slope, by going up and to the right instead of down and to the right, because the slope here is negative 1. The y-intercept is also negative 1. So I go down and to the right. And look, it intersects right there. So here is my coordinate. Looks like it's 3, negative 4. Questions about that? All right. Let's keep taking a look here. We gotta have some more problems here. Oops. Oh, we'll get out there. Let's do 4. Hold on. There it is. Okay. What did the directions tell me to do? Substitution. And I do what I'm told. So if y equals x minus 3, I'm going to plug it right in for y. Look, it's set up for substitution. Yes. Let's go. 3x plus 2 times x minus 3 is negative 6. Right? I take out y from the first equation in its place. I write x minus 3. And now I combine like terms. Or I'm sorry, distribute. 3x plus 2x minus 6. Now, I had some people like freaking out on this problem. Like, I hope we didn't say like no solution or all real numbers. Guys, if I add 6 over to the other side, what's negative 6 plus 6? 0. So it's just 0. Why are we having any issue with that? We just divide by 5. So x is 0. Simple as that. It's not a no solutions. It's not an all real number. 0 is still a number. Last time I checked. Let's plug that back in. Y is equal to 0 minus 3 is negative 3. So 0, comma, negative 3 is where these two lines will cross. Questions about that? And again, you should be checking your answers and writing down all correct answers as we go, right? Okay, let's keep it going then. Let's take a look at number 5 here. This one is elimination. All right, what do we want to do here? How do we want to eliminate? What do I want to do multiply both equations by? Rosalie?
-3.
See, I would do the y's. I would do the y's. And let me show you why. No pun intended. You see that? One's negative, one's positive. I don't have to multiply any negatives with my y values. So all I'm going to do is take this by 4 and this by 5. Let's distribute in. So negative 15x minus 20y is positive 15. That's a y. Nice. This is a negative 4x plus 20y equals 80. I add down negative 19x is equal to 95. Ooh, I really hope 95 is divisible by 19. Oh, cool. I divide by negative 19, so x is equal to negative 5. I plug that back in. Let's go into the bottom. I want to do that because, look, I've got a negative already there. Then I plug in a negative 5 plus 5y is 20. Negative, negative cancels, folks. I subtract the 5. 5y is 15. Y is 3, so negative 5, 15. Negative 5, comma 3. How are we doing on that? Because at that point, we've done all three types of what am I calling? Types of solving. Okay. So at this point, we can pick. Let's do this. I'm going to screen them all over. Okay, I'm going to go through these problems the way I would suggest to do them, whether they be substitution, elimination, graphing, okay? I'm going to go over these problems how I would suggest you to do them. You may have done them a different way, but you may have done them a harder way, okay? So the first thing I'm going to do here is solve number 6 by, I'm going to solve it by elimination. I'm going to solve it by elimination. I'm going to multiply the top by 7. So number 6 here is going to look like this. 7x minus 7y is 70. Bottom equation, negative 7x minus 2y equals negative 16. So this gets me a negative 9y is equal to 54. And when I divide by negative 9, y is negative 6. Plug that back into the top. X minus a negative 6 is 10. So x plus 6 is 10. X is 4. Four comma negative 6. Number 7. I would do number 7 by elimination again. I am going to multiply the top by, well, let's eliminate x's. Negative 3, the bottom by 2. I could have done the bottom by negative. Honestly, there's a lot of different ways I could have done this problem, all the same difficulty. I just picked the x's and I picked the top to be negative. Negative 6x plus 12y is equal to negative 6. The bottom becomes, and all I did was distribute there, positive 6x minus 6y is equal to 18. So 6y is equal to 12. Divide by 6, y is 2. Plug it back in. Let's go into the top. 2x minus 4 times 2. So 2x minus 8. Add 8. 2x is 10. x is 5. I'll give you a minute if you wanted to write that down. I'll erase number 6 and do number 8 there in a second. Anybody still needing the work for number 6? On the left side, the blue work. Okay, I'm going to erase away that work and do number 8 right below it. Okay, number 8, I would do by substitution. Right, I was elimination for 6, elimination for 7, substitution for 8. Because look, it's already set up. Let's plug that in for y. Now watch what happens here. Negative 2x plus 5 is negative 8. Ruh-roh. What's negative 2x plus 2x? Cancels. 5 equals negative 8. What does that tell you? No solution. What does that tell you about the lines? They're parallel. The lines are parallel. Got it. Let's go. Number 9. Honestly, I could really see substitution or elimination for number 9. I'm going to do elimination. I just like elimination better. I'm going to multiply the top equation by 2. So the top equation becomes 6x plus 2y is negative 16. The bottom equation is going to remain the same. What happens to this entire set of equations? Everything cancels. X's cancel. Y's cancel. 16's cancel. 0 is equal to 0. So therefore, what does that tell me about this system? All real numbers. Or if I wanted to say infinite solutions. What does that tell you about the lines? They stack, right? They're one on top of another. They look like the same line. Okay. Questions on 6, 7, 8, or 9? Okay, let's take a look at the word problem. Okay, we got Brian getting some candy bars. Well, and Skittles. Skittles is not really a candy bar, but you know what I mean. Brian buys 3 bags of Skittles and 2 Kit Kats for $5.50. Sherry buys 4 bags of Skittles and 1 Kit Kat for $5.25. What is the price of 1 bag of Skittles and 1 Kit Kat? Okay, I just have to set up my equations here. My 2 unknowns, Skittles, Kit Kat. Right? Those are my 2 unknowns. So Brian's equation looks like this. 3 bags of Skittles, 2 Kit Kats is 5.5. Sherry's equation looks like this. 4 bags of Skittles, 1 Kit Kat is 5.25. And now I just have to figure out a way to solve. Honestly, the easiest way to solve, in my opinion, multiply the bottom by negative 2. I don't want to start solving for y. No thanks. So the top remains the same. 3x plus 2y is equal to 5.5. The bottom becomes negative 8x minus 2y. And then I've got 525 times negative 2. So negative 10.5, right? Okay, add down. This gives me a negative 5x is equal to, and then it's negative 10.5 plus 5.5. So negative 5. Which makes sense because when I divide by negative 5, x is 1. Plug that back in. Let's go back into the original bottom. 4x plus, we know x. 4 times 1, or just 4, plus y is equal to 5.25. We subtract over the 4. Y is 1.25. Guys, for this problem, don't just give me x equals this, y equals this. Explain your answer. Skittles, $1. Kit Kat, $1.25. Now, this last problem was a little difficult. In my opinion, this last problem might be a little difficult for you guys. And here's the reason why. Let me capture it in. Because we really haven't done one like it. Without using graphing, substitution, or elimination. What I'm saying there is, do not try to actually get the coordinate. I don't care about what the coordinate is. I care about how can you tell if there's going to be a solution or not. Well, think about this. How do you know two lines are parallel? What can you see about their slopes? What do you know about the slopes of any two parallel lines?
They're the same.
They're the same. So if the lines are parallel, the slopes should be the same. If the lines lie right on top of one another, what are you going to notice about their equations? They're going to be exactly the same. Okay? So, if the lines are parallel, the slopes are going to be the same. If the lines are coinciding, stacking, the slopes and the y-intercept are going to be the same. It's going to look exactly the same in terms of the slope and the intercept. And then if it's just one cross point, the slopes are just going to be different. Okay, so let's take a look at that. I'm not actually going to attempt to solve for the actual coordinate, but you can manipulate the equations a little bit. Let's take equation 1. Equation 1 says negative 9x minus 2y is 8. All I'm going to do is just solve it for y. I'm just going to move the equation around a little bit. Negative 2y is equal to 9x plus 8. And then when I divide by negative 2, y is equal to negative 9 over 2x minus 4. So what's the slope of that line? Negative 9 over 2. The other line, if it were truly to be parallel, better be negative 9 over 2. Let's check. Here's equation 2. Negative 3x plus y is 2. I add the 3x over to the other side. Y is equal to 3x plus 2. Are the slopes the same? No. So they're not parallel. Are they the exact same equation? No. So they're not infinite. So therefore, if it's not no solution, if it's not infinite solutions, we would know that there is one solution. Just one. Okay. And we see that by finding the slopes of those two lines. If the slopes are different, then the lines are just going to cross one. If the slopes are the same, y-intercept the same line, infinite, slope the same, y-intercept different, no solution. All right, so long, everybody playing along at home.